At the right temperature, heat can begin to break the hydrogen bonds tying water molecules together in their liquid form to generate steam. Nature has harnessed the dynamic relationship water and heat possess for billions of years to shape, nurture, and mold the world we live in. Our ancestors noticed the energy potential of steam, eventually giving rise to the Industrial Revolution. These energetic vapors surround our daily lives, aiding beauty regimens, cleaning routines, and fortunately for us, the medical industry. Channeling previous scientific works, in 1879, French microbiologist Charles Chamberlain fashioned the first working autoclave. Coke, yes that Coke, later partnered with Johnson & Johnson to develop the first industrial autoclave in 1890. Protocols and standard sterilization parameters were born in the 1940s when sterile processing departments became a standard of surgical care. Autoclaves are typically reserved for professional settings, including the food industry, dental offices, and laboratories for their own aseptic needs. But for today's purposes, we will focus on how sterile processing departments utilize autoclaves to process surgical instruments ready for aseptic presentation in the OR. How do autoclaves work? Air in the steam chamber is removed and replaced with increasing amounts of steam. Trapped in the chamber, the pressure within the autoclave rapidly rises and temperatures exceed the boiling point of water. Gravity displacement sterilization cycles depend on the higher density of air to sink out a vent at the bottom of the autoclave while steam is funneled in from above. These cycles are typically utilized for lab media, liquids, pharmaceuticals, and medical waste. However, in my own experience, pre-vac sterilizers are the OR industry standard. The pre-vac cycle uses a high-powered vacuum to rapidly remove all the air out the vent to promote the downflowing steam, the ability to adequately penetrate instrument sets. Operating temperatures for autoclaves start at about 121 degrees Celsius, that's about 250 degrees Fahrenheit, and for standard pre-vac cycles, 132 degrees Celsius, which is 270 degrees Fahrenheit, about, typically at a pressure of 15 to 20 pounds psi. The steam must directly contact the items being sterilized, and the temperature must be high enough to kill the endospores to achieve complete sterilization. The CDC confirms the going standard where pre-vac cycles must maintain 4 minutes of sterilization from 270 to 275 degrees Fahrenheit. On this printout, we have double-checked the machine has reported the indicated parameters to ensure a successful cycle. The cycle will destroy all microorganisms except for prions by the irreversible coagulation and denaturation of enzymes and structural proteins. To maintain patient safety and minimize nosocomial infections, many methods of quality control and indicators of successful sterilization are required. Chemical indicators are placed inside each set to confirm adequate steam exposure and penetration was achieved when the black line reaches the proper line. Externally, package integrity is carefully inspected. External indicators include heat-sensitive tape for wrapped items and box locks for containers. Upon exposure, the heat-sensitive lines in the tape will turn black, along with the dot on the box locks. All items are fashioned with a lot sticker indicating the sterilizer and load number and the date to enable tracking in the event of an infection or a load recall. For the first load of the day in each sterilizer, we ensure the autoclave meets air removal standards with the Bowie-Dick air removal test. The second loads of the day, loads with implants, or loads following a service, include a biological indicator spore test. Ours uses a liquid suspension of the endospores of Geobacillus styrothermophilus to determine whether the endospores are killed by the process. Our book states the endospores of the obligate thermophilic bacterium are the gold standard used for this purpose because of their extreme heat resistance. Like any proper science experiment, a control biological with the same lot number is incubated. Our machine uses fluorescence to check and read the test. A control must alarm a positive result. It will turn yellow, allowing us to visually confirm growth, while a passing test will remain purple and negative. Sterilization is just a step in the cycle of reprocessing reusable surgical instrumentation. After sterilization, sets must be safely stored in a dedicated sterile storage area with positive airflow. At surgery completion, donned in PPE, in a negative airflow decontamination room, all visible gross soil is removed utilizing enzymatic solutions, ultrasonic cavitation, and elbow grease prior to loading into a washer disinfector unit. Upon cycle completion, instruments are safe to handle without PPE to inspect, assemble, and package prior to another round of sterilization. A final critical step in the aseptic technique utilized in the OR is ensuring proper surgical attire, maintaining a sterile field, and the aseptic presentation of instrumentation. Autoclaves remain the #1 aseptic process for reusable, heat-tolerant surgical instrumentation. Shout out to my wonderful coworkers for their demonstration and my boss Cassie for allowing me to share our sterile processing department with our class today. Thanks.